All right, we're going to be continuing with inverse functions, and this will be the end of chapter 4, inverse functions for the sine, cosine, and tangent. And what I want to start with today is just redrawing the inverse functions for the three. We did the cosine and the tangent yesterday, so a quick review on the cosine was the inverse graph went from 1 to -1 on your x's, and then it went from 0 to pi on your y's. So for the tangent, we had asymptotes, and it went from positive pi over 2 to negative pi over 2. And for the sine, which was part of your homework, it looked like, not like that, but it did look like this, which means that it went from a negative pi over 2 to a positive pi over 2. And on these three graphs, you can see the range is on the y-axis, and that's what's written right up above it. Those ranges are very important because that's where they're defined, and that's where your calculator is going to give you answers. So, for example, I wrote down a way that you can write that as a shortcut, and the shortcut is up here. And remember, these axes, this remember is from Santa Claus. It's your standard angles, or your angles in standard form, going from 0 to pi to 3 pi over 2 all the way around. So these axes are not the same as these axes. So what's happening? Sine inverse is going from negative pi over 2 to positive pi over 2 for your angles. That means in your SOHCAHTOA graph, your Santa Claus graph, you're really going from the first quadrant, which is 0 to pi over 2, and the fourth quadrant, which is 0 to negative pi over 2. That's what your range is. So I'm looking at these two quadrants where my angles are. That's defining them in there. Cosine, 0 to pi, that's the first and the second. Tangent, and these are inverses, negative pi over 2 to positive pi over 2, that's the first and the fourth quadrants. So all of my angles are going to be contained in those quadrants per the inverse function. I have to know which quadrants are defined as so I can put in the right answer. Now what I want to do is actually go to the graphing calculator and just plug numbers in and show you that your graphing calculator is going to be giving you numbers that are within these ranges. They won't give you any answers outside of the range. So this is strictly the inverse functions. Remember, functions are each x can have exactly one y. So what I'd like to do is go to your graphing calculator and start putting in some values and showing you that, yes, it's the same idea as what's happening here. Let's go to inverse sine, and my mode, just so we're clear, is on radian mode. And when I do the sine inverse, I can just pick any number. Remember, when I do the sine inverse, what I'm really getting is an angle. The sine of this answer, this angle, is equal to the number that I put in. So if I just put in 0.5, you're going to see that that's going to give me 0.52 radians, which is positive. That would be in this quadrant here. But then if I did the second enter and bring up the same exact thing, and I insert a negative sign, look what happens. It gives me a negative angle. Why is it giving me a negative angle? Because this is where it's defined. This is the negative number. the angle is going to be down here in the fourth quadrant. Now, if I did the same thing for tangent and put in 0.5, you're going to see it's going to be a positive angle. And if I put in a negative sign, and let's just try this one more time here. So it's tangent inverse of a negative 0.5. That answer should be a negative because we're defined in that fourth quadrant there, and it is. And now watch what happens with the cosine, inverse cosine. Inverse cosine gives me a positive angle where my number is positive, but where my number is negative, and when I insert a negative sign, I'm going to show that this is no longer going to give me a negative number. It's actually going to give me a obtuse number. It's going to give me an angle in the second quadrant, which is from pi over 2 to pi, because that's where that is defined. It's not in the fourth. It's in the second. So when I hit enter, you're going to see that that is actually a number between pi over 2 and pi. All right? So that should make sense now why your calculator gives you answers depending upon where your inverse functions are defined as functions. I want to go through a couple problems here. Keeping in mind where these things are defined, I'm going to answer these questions now because this -1 means function, inverse function. It's only going to be one exact answer. Sine inverse of 1/2 really means the sine of what angle is equal to 1/2. The sign of question mark equals 1/2. Well, if I do radians and I'm looking at my table, you know at this point you should be comfortable that that's equal to pi over 6. It's positive, it's in the first quadrant, that's where it's defined. If it were -1/2, that answer would be a negative pi over 6 because it would be defined in that quadrant, the fourth one. Cosine. Cosine is defined here. So it's a negative number. That means I'm really looking in the second quadrant. So what's the angle? Well, I remember the reference angle. My reference angle is going to be actually pi over 6. But that's where it's positive. Where it's negative really is going to be, that's where it's pi over 6. So my angle that I'm looking at is going to be 5 pi over 6. Remember, it's defined in the second quadrant, so it has to be here. It can't be down in that fourth quadrant. It has to be that obtuse angle because that's where it's defined. Tangent. I remember for the tangent, it's going to be a positive numbers here, negative numbers in the fourth quadrant. So I remember that it's pi over 4 is equal to the reference angle. In the last quadrant, the fourth quadrant, this is going to be a negative pi over 4. If I put, for example, 3 pi over 4 for an answer on this one, it's going to be wrong because it's not following where it's defined as. That's why you have to know these little diagrams to help you out with those angles. Now, that is one way of solving these inverse function problems. It's not the only way. If you have numbers like 0, 1, -1, I would draw the graphs at this point. I would not look at the unit circle like you've done in the past. And because when you draw the graphs, you're thinking, what's your x and what's your y? So these are just the cosine graph. This is the sine graph. I'm not doing inverse graphs anymore. I'm just doing the regular. So when I am asked with this question, what I'm really asking is cosine of what angle is equal to 0? The cosine of what angle is equal to 0? And so I can look on this graph and I can see these are my angles, right? So this is really pi over 2. And where my y is 0, what is my x? My x is going to be pi over 2 on this one. So the cosine of pi over 2 equals 0, and you're done. Pi over 2 is within the range of cosine. What about this? Our cosine of 1 is equal to 0. That's the same thing as inverse cosine of 1. If I go back to this graph again, where is the y equal to 1? At this point right here. What is the angle? It's at 0. So I know that's how this is equal to 0. You could go back to the unit circle and do your x over r, just like you did before. But I find personally it's easier to do a quick drawing and figure out what your points are and get your answers off of that. Because we've done these problems before with unit circles. Arc sine of -1 equals, well, I draw the sine graph. Now this is kind of an interesting problem because if you put in -1 here, you have this point, but you also have this point. Which point is it? It's the point where it's in the range where the inverse function is defined. Where is the inverse sine defined? It's defined if it's a positive number, it's here. If it's a negative number, it's here. So my angle has to be this angle right here, a negative pi over 2. So this is negative pi over 2. It's not 3 pi over 2 because that would be all the way down here, which is not going to be defined. Now, let me back up a little bit more. 3 pi over 2 isn't written the same way as that's a different angle than what the range says. The range for the sine says that your y's can be between negative pi over 2 and positive pi over 2. 3 pi over 2 is not part of that range. That's why I want to choose the negative pi over 2. There's one more type of problem, and this type of problem is where it's easy if you see it and learn it the first time. Students make mistakes on this because they forget how to set it up. And so the main thing on these problems is just they should be very easy if you know how to set them up. The problem looks confusing. Don't worry about these. That's just putting them in your calculator and getting an answer. But if you have on number 8 here, the sine of tangent inverse 3 over 4 is equal to what without a calculator? The whole trick on this, these types of problems, is draw a triangle. You don't care what your angle is. Remember, an inverse function is really an angle. You're getting an angle. You don't care what your theta is. You just want to use theta to get the sine of theta. So because you don't care what theta is, you can make a triangle and put in theta here. And remember by SOHCAHTOA that the tangent of theta is opposite over adjacent, so I know that that's equal to 3 and that's equal to 4 because tangent theta equals 3 over 4, right, when you switch it around. At this point, the problem is very easy. It's a 3, 4, 5 triangle, And now you're just finding what is the sine of theta. The sine of theta is just going to be 3 over 5, opposite over hypotenuse. So you're setting up a triangle and just using SOHCAHTOA in these problems. They're fast, they're quick, just get the triangle down and put the information in. The only other question you may have is one with a variable. And it's the same type of question. It says, what about the sine of this angle, which is cosine inverse of x? Well, to find this answer, you have to remember x is really the same thing as x over 1. X over 1 is where you draw the triangle again. You put in your theta, and adjacent over hypotenuse is x over 1. The only missing piece is what about this length? And you're just going to use the Pythagorean theorem to find that missing length. Well, you don't know what to label that, but that's what I want to solve for. So it's just going to be 1 squared equals x squared plus, well, you can do question mark squared if you want and just solve for a question mark, or put a variable in. Doesn't really matter. This becomes 1 minus x squared equals question mark squared. The question mark is really equal to 1 minus x squared. 1 minus x squared under the square root. It's positive or negative, but because it's a length, it's going to be positive. Now the problem is easy. What is the sine of the angle again? The sine of the angle is that. That's the end of the new topics in Chapter 4. We went over today inverse trig functions, sine, cosine, and tangent. We went over where those are defined, what are the ranges, and then we applied the inverse functions to determine what the inverse trig function of a number is by looking at those specific ranges. All right, fill in your big rock sheet. Make sure that that's all done. Your problems, your word problems that you have, those are due tomorrow. I certainly hope you did not procrastinate on those, because you're going to have a lot of work to do if you did. And you won't be able to check your answers today. So check your equations with me in this period to know if you got them set up correctly or not.